This will be an examples on your Norton, thevenin, and your maximum power transfer. Your Norton and thevenin are just the source transformation of each other. So you see, in a thevenin circuit, we have what you call our thevenin voltage, your VTH, and then we have your RTH or your thevenin equivalent resistance, and then your RL. If there is no RL, the RL will be shorted. So shorted lang siya pag walang RL. This is your RL. And then your VTH is just, you will source transform this VTH and your RTH to get the Norton equivalent. So the principle of source transform is that the arrow will follow the positive terminal or positive polarity. So IN or your IN is equal to VTH over RTH. Okay, and then we have your resistance RTH in parallel with your IN and RN. RTH, and then we have our RL. Okay, our RL. Okay, so if wala namang RL sa kabila, this will act as open. Okay, so this is the properties of your Norton and thevenin equivalent, wherein they are just the source transformation of each other. So pwede mong kunin yung IN via using your VTH and your RTH. Okay, so what is this VTH and RTH and IN? Basically, your IN is what you call your short circuit current. That means that this is the maximum current na pwedeng pumasok sa circuit mo. Next is your VTH. Yung VTH natin is, this is the voltage or the voltage in the terminal RL. This is the voltage in your terminal RL when you will remove it. So your thevenin voltage is the representation of the sources in your thevenin equivalent circuit. It represents all the sources or the values of the sources that will have that will affect the passive element. Represent all the sources affecting the passive element. And your RTH is the thevenin equivalent or the equivalent resistance of all the resistance. Equivalent resistance of all the resistance. Within the terminal RL. Within terminal RL. So your RTH is basically the representation of the resistance in the circuit. Okay, notice that your sources thevenin and norton equivalent is that at independent source at independent sources, which is basically your case 1. So pag nakakita kayo ng independent source, independent source, basically we have two, right? So we have our voltage source and our current source. When you are performing uh, the getting the value of your RTH, we will, or your sources will act as shorted for voltage source and open for current source. So magiging ganito siya. Shorted. So if this is my terminal, so magiging shorted lang yung voltage source natin. And then yung current source natin is mag-open lang siya. Okay? If these are independent sources, this is for your case 1. This is for your case 1. But how about if there is dependent source? So at dependent sources, you will short the independent voltage source, open the independent current source, but let the dependent source. So meaning you will not open them or close them. Why? Basically, these dependent source are the sources that cannot stand alone, which means that they need the passive elements or resistance in order to produce a voltage or voltages and current. So therefore, we will let the dependent source alone. So hindi natin sila gagalawin, we will let it be. And then parallel or assume a voltage or current source in the terminal, in the RL terminal. Then perform. Then after getting the value of pag current source yan, so at current source, ang linagay mo sa terminal ng RL mo, so therefore find for the value of Vs or the voltage source among the terminals with the dependent source. So at voltage naman, if you will series of voltage to the terminal of your RL, so find the value of Is. And then after that, we will get the RTH equals the at current, pag current yung siniris mo, so we will have Vs all over the assumed current source. Take note that that is an assumption. Pag magpaparallel ka, magsiseries ka ng current or voltage source within a case 2 or a circuit with dependent source. Or if you will series a voltage source, therefore we have assumed voltage source divided by your IS calculated among the circuit element. So, ganun lang yun. So, this is a summary of your Norton, Thevenin, and maximum power transfer. Take note that your maximum power transfer is just always equal to P max will always be equal to VTH squared all over 4 RTH, wherein P max occur at RTH is equal to RL. Okay, that is just a recap for our discussion. Okay, so let's have our first example. Our first example will be pure, or your case 1, pure independent source. So we will use the circuit diagram in your superposition theorem in order to show you that whatever theory or theory of circuits that you will use, you will have the same value of current or voltage as long as you have the correct assumptions. So let's say I have a positive 20 volt source, and then I have a 2 ohm resistor, and then another 1 ohm resistor, a current source going down, which is your 2 ampere, and a 1 ampere and a 3 ohm resistor. Okay, and another 4 ohm resistor and negative 16 volt source, independent source. Okay, so that is our circuit diagram. So this is our circuit diagram, right? So what will we? So the first thing to do is to analyze the circuit, right? If we will solve for the value of your I, so take note the value of I is here. Okay. So calculate the power delivered to the 3 ohm resistor. The question will be calculate the power delivered at 3 ohm resistor. And also find for the value of I. So this will be our I. It is understandable that your RL will be your 3 ohms. Okay? So solution, my RL will be equal to 3 ohms. Okay, the best in getting your VTH and or your IN, so the best thing to do is to draw first the circuit, your RTH, and then your RL, and then we have our VTH. So our RL is already equal to 3 ohm, right? Yung wala na lang is our RTH and our VTH. So how we solve that one? So go back to our assumptions or to our rules that in the independent source, your voltage source will act as shorted and your current source will act as open. Okay? So therefore, solving for RTH. Actually, when you are solving for RTH, may dalawa yan eh. Pag tinanggal natin to, if you will remove your 3 ohm resistor, so we will have a value equal to positive, circuit diagram equal to positive negative 20 volts, 2 ohm, and then another 1 ohm, and then your 2 ampere source, and then your 3 ohm. So your 3 ohm will be removed. That will be your terminal A, B. So take note, yung current nyo pababa siya. Okay? And then we have our 3 ohm, so it will be removed. And then we have our negative 16 volts. Okay. So we would analyze this circuit by simply having the instinct whether if I will make a source transformation of this circuit, can I have a better result or an easier circuit diagram. So you see that upon removing your 3 ohm, your 2 ampere is in parallel with 1 ohm. Therefore, I may perform a source transformation. So if I will perform a source transformation, so your 1 ohm resistor, if I will analyze later the VTH will have a current equal to 0. So therefore, it would be easier for me to solve for the VTH. So therefore, the best thing that I will do is I will first transform this one and then get my RTH. So using source transformation theorem in my 1 and 2 ampere, so I will have, so 1, 20, 2 ohm, then our terminals AB, okay, and then 2 ampere multiplied by 1 ampere, and then the current source is going down, therefore I will have positive, negative 2 volts, and then a series resistor 1 ohm. Okay, and then my sources, so actually this is a 4 ohm resistor. Okay, so 4 ohm resistor, so we'll have a 4 ohm resistor with a negative positive 16 volt source. That is our new circuit diagram upon source transforming your 2 ampere and your 1 ohm. So take note that if there is already a current in your RL, so therefore carry that upon going into your VTH and RTH circuit diagram. So since we already have this new circuit diagram, therefore I may now solve for my RTH. Solving for RTH. So therefore, this will be our terminals, okay? So take note that these are all voltage source. So short natin yan. Shorted, shorted, shorted. So therefore, we will have a new circuit diagram which is 2 ohm in parallel with 1 ohm and the terminal AB. Okay? And then we have our 4 ohm resistor. Okay. So how will you solve for RAB? Take note that your RAB will be the terminal wherein you will solve for your total RTH. which is basically equal to the parallel combination of your 2 ohm and 4 ohm. Take note that they have parallel terminals. So in parallel with 2 ohm and 4 ohm, so upon performing their parallel combination, it would be in series with 1 ohm. Okay? So therefore, our RTH is equal to 1 divided by 2 raised to negative 1 plus 4 raised to negative 1 plus 1 ohm. So our RTH will be equal to 7/3 ohm. That is our RTH. And then we will solve for our VTH. So solving for VTH, we will have the circuit diagram, which is this is your positive, negative, 20 volts, 2 ohm resistor, and then your so positive, negative to kasi nasa baba yung arrow. So we have negative, positive 2 volts in series with our 1 ohm resistor, and then this is your terminal AB, terminal AB. Take that, this will be positive, negative. Okay, and then we have our 4 ohm and 16-volt source. Notice that if your AB will act as open, therefore you may not include this in performing your KVL. Why? Because open yan. And your 1 ohm is already zero, has zero voltage because there is no current entering to your 1 ohm because of the open source. And then, take note that the value of your 2 volts will still be there. Okay? So if you will perform a KVL later on, you must not, you must include your 2 volts upon performing your KVL at this side. But first, we will perform your KVL at the loop, the whole loop. Okay? Because series, para nagiging series combination na yan, kasi zero naman yung current na pumupunta dito. Take note that your I1 is equal to 0. Therefore, your V1, which is the voltage at your 1 ohm, is equal to 0. Okay? So, we'll have, so, papasok tayo sa negative 20 minus 16 plus the currents of 4 plus 2 ampere multiplied by our I total. I1. Sabihin natin IX. Okay, so I will say, or I will denote that the current of this loop will be IX. Okay, para hindi na tayo malito sa I1 because your I1 is already here. Your I1 at 1 ohm. Okay, so therefore, we will have a value equal to negative 36 volts plus 6ix, wherein our ix is equal to is equal to 36 divided by 6, which is equal to 6 ampere. which means that this is the current or the value of the current Ix. Okay, next is that in order to get your VAB, so or your VTH, you will have a loop solving for VTH at this mesh. Okay, so performing KVL at mesh 1. So take note that your 1 ohm, so lalagay pa rin natin yan, V1, so V1 positive, plus VAB, so plus 2 IX. So bakit positive yung IX mo, sir? Take note, yung direction natin is going with the flow of your IX. So positive siya. So plus 2IX minus 20 volts minus, so papasok tayo dito sa negative ng 2 volts. So minus din to. Minus 2 volts. Take note that our V1 is equal to I1 multiplied by 1. But our I1 is equal to 0. So therefore 0 yan. Plus VAB plus our IX is equal to 6 ampere. So multiplied by IX minus 20 minus 2 volts. So tatanggalin muna natin yung unit para hindi tayo magkalituhan. Take note that your 2 ohm multiplied by IX is also volts. So therefore we'll have VAB, so plus 0 plus 12 minus 22 equals 0 via conservation of energy. So we'll have VAB is equal to 12 minus 22 is 10 volts. This is our VAB. So therefore, so upon solving your VAB, so we'll substitute the values of your RTH, which is 7/3, and then the values of your VAB, which is 10 volts. Okay? So upon solving, so we will have a value equal to positive, negative 10 volts. Then your RTH, which is 7/3. Then your RL, which is equal to 3 ohm. And then your 10 volts VTH. So we will perform a KVL. Okay? So upon performing KVL, you will see that we'll have negative 10 volts. So take note that the I is within the direction of this one, so this will be positive. Plus 3 plus 7/3 because they are now in series, multiplied by our I equals 0. So therefore, our I multiplied by 3 plus 7/3, which is equal to 16/3, is equal to 10 volts. So therefore, our I is equal to 10 divided by 16/3. It is equal to 1.875 ampere. The power in your 3 ohm resistor is equal to I squared R, which is equal to 1.875 squared multiplied by R, which is equal to 3 ohm. So we'll have a power equal to times 3, 1.875 squared times 3, we'll have a power equal to 10.55 watts. So this is the value of your, or this is the answer. Take note that if you will see my previous videos which has this example, they have the same current and wattage. If you will transform this one into its IN, so just a source transformation of your VTH and your RTH into current source transformation. So mapapansin mo maging parallel lang yung RTH mo and your RL. Okay? And your ITH will basically be equal to VTH divided by your RTH. Okay? Or your IN. Right? So this will be your example number 1.